Let's continue on to section 5.3. We're going to now use this in a slightly different way, and there's a couple ways to solve these and attack them, so I'm going to switch it up a little bit here. Each of these is asking, number 1 and 2 are each asking, if this point is on the unit circle, and how we can explain or show our reasoning. Now there's a couple ways to attack this problem, just like math and a lot of our other topics that we've talked about. We're not stuck with just one way to do this. So I'm going to use one way to solve number 1. If you like it, you could use it to solve number 2. Or if you don't like it, wait until we do number 2 and see if you like that way better. Okay? Number 1, well, it's telling me that I have a known x coordinate, and it wants to know if the sine of 4 pi over 3 is the correct y coordinate that would go with it if it's on the unit circle. One of the fast ways to go about this, again, if you have that printed off table of values that we have going on here, I have a negative x and a positive y. Well, actually, I don't even know if it's a positive y. I have a negative x and what looks like a positive y. 4 pi over 3, when I'm looking at my table of values, I find 4 pi over 3 in quadrant 3. And the fast way to check this, which might be the way that you like doing it, is to see that yes, in fact, the x coordinate is negative 0.5. And we know already, because we wrote on our little table of values here, that our vertical coordinate is the sine, and so sine of 4.3, sine of 4 pi over 3 equals negative 0.87. If you're not sure, you could always go to your calculator. This is a third way, essentially, to go about doing it. First of all, check that your mode is in radians. Okay, if you have a scientific calculator, if it says deg at the top for degree, you need to put it in rad mode. Okay, so find the mode for radians. And then we want to think, is the sine of 4 pi over 3, there's that negative 0.87 that is on our chart. Everything checks out. Okay, so we know that we're in quadrant 3, actually, so it tells us that. So both of them would have to be negative. Okay, so is the point negative 0.5 sine of 4/3 pi on the unit circle? The way we could explain our reasoning is we could say, yes, at angle 4/3, 4 pi over 3 radians, the x coordinate is negative 0.5 from our coordinate chart. This is one way to go about it. Okay, so I know that if I'm in quadrant 3, the one that's going to have to go with negative 0.5 is that sine of 4 pi over 3. Now, a second way to go about doing this is still going to involve our chart, and our chart is really the easiest way for us to be able to tell this kind of stuff. But I'm going to do it without the chart to show it. So that point, it's asking if this is on the unit circle. Okay, so we have a point negative 0.5 is our x coordinate, sine of 5 pi over 6 is our y coordinate. We want to know if this is on the unit circle. What that should mean is that our x squared plus y squared should equal 1. If it doesn't equal 1, it's not on the unit circle. So if this equals anything other than 1, it's not going to work. We know that the x is negative 0.5. Let's figure out, now that we have our calculator in radian mode, let's figure out what sine squared of 5 pi over 6 is. So sine squared, sine of 5 pi over 6, close the parentheses. Okay, that's what that's telling us, is that we want to have that sine squared, not to square just the angle. Okay, we want sine squared. And negative 0.5 squared is also, oops, sorry, I have to put it in parentheses, is also 0.25. And there is no way that 0.25 and 0.25, they do not equal 1. So this would not be on the unit circle. Because the Pythagorean identity doesn't hold true. So I'm just going to shorthand that into Pythagorean identity isn't true here. So we broke math. Or we break math, we just know that that's not true. It didn't happen. So it's not on the unit circle. I can again find out like what's going on at this 5 pi over 6 if I wanted to use my chart instead. 5 pi over 6 is showing up here in quadrant 2. And I see that my x coordinate, my horizontal coordinate, should be negative 0.87. And it wasn't negative 0.87, it was negative 0.5. So I again know that the coordinates aren't matching up for the given angle, or I could say that when I calculate it as part of the Pythagorean identity, it fails. So suppose that sine theta equals negative 0.5, and that our angle is in quadrant 4. So we're somewhere down here. Now we're still stuck with this sine. That means our y coordinate is negative 0.5. So if our unit circle looks like that, we have our y coordinate at negative 0.5. What is the exact value of cosine theta? Explain or show your reasoning. Again, we could do this in a couple different ways. We could use method 1, and that's to use the Pythagorean ID, the Pythagorean identity. If we know that sine cosine squared plus sine squared equals 1. We know that sine is negative 0.5. We need to square that sine value. Okay. And we need to find out what our cosine squared would be. Negative times negative is a positive. 0.5 times 0.5 is 0.25. That's half of half. So for this to be true, something plus 0.25 equals 1. That cosine squared has to equal 3/4. I'm going to put this into a fraction now. Okay. I'm doing that because then when I go and take the square root of both sides, I am finding what that cosine value would have to be. Cosine would have to be square root 3 over 2. Remember, it's square rooting the top and square rooting the bottom. Square root 3 over square root 4. Okay? So the exact value, it's asking for exact, not our decimal approximation, would have to be root 3 over 2. The other way to do this is to use chart. Okay, so you're seeing how useful this chart is to have handy. We're looking at a sine of an angle at negative 0.5 in quadrant 4. So I'm going into quadrant 4. I'm looking for a sine value. Remember, sine is our y, that's our x, of negative 0.5. And I see that our cosine value has to be a positive number. It actually has to be positive 0.87. I think I forgot to mention that here, that I know since it's in quadrant 4 that I have to have a positive cosine value, right? So it has to be that positive root 3 over 2. Reinforces it here. So maybe you just want to remember that that decimal approximation of 0.87 equals the square root of 3 over 2. That's our exact value. So there's our approximately equal to, here's my exact. We may start adding some other ideas there, so it's good to have that chart handy and ready. There we go, lesson 5.